Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which I'll go through what you need to know for our upcoming test. So it covers all the topics listed on your screen. The first 5 in black are from the algebra topic and the next 3 from the percentages topic. So I'll go through those one by one. Let's start with substitution. So substitution is when you're given an expression like this and you exchange pronumerals or letters for a value. And evaluate just means give the value of. So here, I'm not going to spend a lot of time talking about it because you can just let your calculator do the work. But just make sure if you're ever substituting a negative number, put brackets around it. So for c squared, put brackets around it, otherwise you will get the wrong answer. So you could literally just put this in your calculator and let your calculator do the work. So the answer you get is minus 26. So perhaps put that in your calculator and make sure you get the right answer. So that's all I want to say about substitution. Just get your calculator to do the work. Now let's go through expanding and simplifying. So to expand, when we only have one set of brackets, we use the distributive law. So that means we distribute the thing out of the brackets to everything inside the brackets. Here, we would times the 4 by x to get 4x, and we times the 4 by 2 to get negative 8. So this is our answer. Expanding means you start with brackets and you end up with something that does not have brackets. Now this one can't be simplified any further because 4x is a term, minus 8 is a term. They are not like terms. You can only add or subtract terms if they're like terms. But you can see we multiplied fine. We can still multiply 4 and x even though they're not like terms. You can multiply and divide any terms you like, but you can only add or subtract them if they are like terms. So if we're given something like this, where there are 2 sets of a bracket, what we're going to do is expand the first set of brackets, expand the second set of brackets, and then simplify our answer by collecting like terms. So starting with the first bracket, 3x times 2x. So 3 times 2 is 6. X times x is x squared. Please make sure you don't mess that up. X plus x is 2x. X times x is x squared. So that's why when I went 3x times 2x, I didn't get the answer of 6x or 5x. I got 6x squared because there's an x times x. So finishing off the first bracket, 3x times minus 5y. This term and this term are not like terms, but I can still multiply them together. So this time it's 3 times minus 5, which gives you negative 15, and I just write the pronumerals. Now expanding the second bracket, this is not an x out the front, it's a negative x. So I times negative x by y, that's a negative times a positive. Negative times positive gives you a negative. Now I have negative x times negative x. Negative times negative is a positive, and as I said before, x times x is x squared. So this is what we have from expanding the brackets. Now we're going to simplify by collecting like terms. We can only add or subtract terms if they're like terms. So 6x squared and x squared, they are like terms. They both have an x squared as the pronumeral. So 6x squared plus x squared. If you have 6x squareds and you get another x squared, you now have 7x squareds. Similarly, minus 15xy and minus xy, they are like terms because both terms have one x and one y. They have the same sequence of pronumerals. So what I do is add the coefficients. I go minus 15 minus 1, or minus 15 plus minus 1. That's negative 16. And I keep the same letters. This is the final answer. Can't be simplified anymore. These are not like terms. So not only did we perform expansions with one set of brackets, we performed expansions with 2 sets of brackets being multiplied together. They're called binomial expansions. So if I have something like x plus 3 times x minus 4, remember for these ones, I use the FOIL method. The FOIL is for binomial expansions. So the FOIL method just tells you what to multiply. It helps you keep track. We do the first thing in each bracket, the thing on the outside of each bracket, thing on the inside of each bracket, and then the thing that's last in each bracket. The idea is we need to multiply everything in the first bracket by everything in the second bracket. So this is a binomial expansion because each set of bracket has two terms. That's why we call it binomial, two terms. So we're going to use the FOIL method. So we go firsts, you're always timesing. So x times x is x squared. Then x times minus 4 is minus 4x. That's the thing on the outside of each bracket. Now, insides are the thing on the inside of each bracket. So it's positive 3 times x is just 3x. And then L, last, is the thing that occurs last in each bracket. So it's, in this case, 3 times negative 4, which is negative 12. So we can simplify this because we have some like terms. X squared and 4x are not like terms because this has 2x's, this only has 1. Minus 4x and 3x are the like terms, so collecting them, leave the x squared alone. Minus 4 plus 3 is minus 1. You can just write minus x there. And then the minus 12 doesn't have any like terms, so we leave it as it is. So when we have binomial expansion, you have the same thing in each bracket, but one's a minus and one's a plus. This is a special type of expression called difference of two squares. So if I go and expand this using FOIL, I get x times x, which is x squared. Outsides is x times positive 5. Insides is minus 5 times x. And then last is minus 5 times 5, which is negative 25. So remember, negative times a positive is a negative. So these two middle terms end up cancelling each other out. 5x minus 5x is 0. So when you have the difference of two squares, you end up with an answer that's only two terms. It is a perfect square minus a perfect square. That's why it's difference of squares. Difference means minus. So that only happens when you have the same thing in each brackets, but one's a minus, one's a plus. So sometimes you'll get a binomial expansion that looks like this. You have an expression that is squared, and squared means multiply it by itself. So we can just write it out like this, 2x minus 3 multiplied by itself, and then we use the FOIL method as normal. So now 2x times 2x is 4x squared, 2x times minus 3, minus 3 times 2x, and then last is minus 3 times minus 3, which is a positive. So these two terms in the middle, they are like terms, but they don't add to 0. Minus 6x is minus 12x. Negative 6 minus 6 is negative 12. Whenever you have a perfect square, your answer should have 3 terms, or you've done something wrong. What people sometimes do wrong when they get something like this is they just square the first term, which is this one, and then square the second term. But there is a middle term. So if you get a binomial square, just multiply it by itself using the same process of FOIL. All right, let's now look at factorization, which is going the other way. So on the previous slide, I showed you how to expand. That's where you start with something like this, and you end up with something like this. You start with brackets, you end up with something that doesn't have brackets. So factorizing is going the other way. You start with an expression that has no brackets, and you write it with brackets. Factorizing means write it as something times something. Just like if you were to factorize the number 36, you could write it as, say, 9 times 4. That's factorizing. So there are a few different methods for factorizing. So if there's two terms that you need to factorize, you used highest common factor or difference of two squares. And I'll go through some examples. For 3 terms, we only have one way to do those. It's the times plus rule. And I'll go through that as well. So we'll start off with this one, which is just a linear expression. So we've got 1, 2 terms. So whenever you've got 2 terms, first try highest common factor. So ask yourself, do the 2 terms have a common factor? Well, here they do. 2x and minus 16, they have a common factor of 2. So what you do is you write the highest common factor out the front of the brackets, and then in the brackets, you divide each term by the highest common factor. 2x divided by 2, In other words, what do you times by 2 to get 2x? And that's just x. Then I say, what do I times by 2, the highest common factor, to get not positive but negative 16? You times 2 by minus 8 to get 16. And this is my answer. I've written this expression as something times something. If I were to expand this, I would get this. So again here, two terms, they have a common factor. So 30 and 40 have a common factor of 10. 10 goes into both of them, so I write that out the front. But sometimes the common factor will also contain letters. This term here, 30AC and minus 40CD, they both have a C. They have a letter that's common, so I need to write that out the front. So I say, what do I times by 10C to get 30AC? Well, you need to times it by 3 to get to 30, and A, so you have 30AC. Then I say, what do I times by 10C to get minus 40CD? Well, I need to times 10 by minus 4 to get to minus 40, and then I need the D there because there was a D here. If I were to expand this, I would get this. Now, normally, we're factorizing quadratic expressions. They're expressions with an x squared term. So for something like x squared minus 6x, well, there are two terms here. This time, the highest common factor is not a number. The highest thing that goes into both of them is an x. And x is common to this term and this term. So x goes out the front, and then I say, so what do I times by x to get x squared? Well, that's just x. What do I times by x to get negative 6x? You times x by negative 6 to get that. Once again, if I expand this, I get that. So these were all examples of two terms, which are called binomials, that used highest common factor. Sometimes you need to use difference of two squares. So if I have something like x squared minus 9, this term here and this term here don't have a common factor. I can't use the highest common factor method. Instead, I need to use difference of two squares. So how do I know that? Well, this is a perfect square. 9 is a perfect square. It's 3 squared. I have a square minus a square. Difference of two squares. So when you have that, you do the opposite of what I showed you on the previous slide. So what you do is you set up your brackets, 2 brackets this time. You square root the first, square root the second. Square root of 9 is 3. 1 gets a plus, 1 gets a minus. Because remember I showed you on the previous slide, when you have 2 brackets, you have the same thing in both brackets, but one's a plus and one's a minus. When you have that, if I were to expand this, I only get 2 terms. So let's look at another example of this. This probably won't look like it, but if I have something like 9x squared minus 64, this is actually the difference of two squares. 9 is a perfect square and x squared is a perfect square. This first term is a perfect square. 64 is a perfect square. It's 8 squared. So I'm going to factorize this in exactly the same way. I square root the first term, so square root of 9 is 3. Square root of x squared is x. 3x times 3x gives you 9x squared. Then I square root the second thing. Square root of 64 is 8. 1 gets a minus, 1 gets a plus. If I were to expand this, I would get this. So note once again, 9x squared and 64 have no common factors. There's no number other than 1, but that doesn't count. No other number that goes into 9 and also 64. I can't put an x out the front because this term doesn't have an x. X is not common to both. So that's why I needed another method rather than highest common factor. So one more point I want to make is that when you're using highest common factors, sometimes the common factor is in brackets. So let's say I had to factorize this. Once again, I've got 1, 2 things, right? Now, this isn't the difference of two squares. This isn't a perfect square, nor is this. But the common factor here, the thing that's common, is what's in the brackets. So what I do is I write the thing in the brackets, the highest common factor, I move that to the front. So then I can just write 3 plus x in the second bracket. That's what's left over, because I'm doing the same as what I did up here. I'm saying, what do I times by this bracket to get this? Well, I've times 2x plus 1 by 3 here. Then I say, what do I times by the highest common factor to get this? Well, I have times 2x plus 1 by x here. So that's why I was able to write that in there. All right, let's now look at examples involving 3 terms. So let's say I have the expression x squared plus 6x plus 8. This is a quadratic expression because of the x squared term. So what we do when we're doing these ones with 3 terms, 1, 2, 3 terms, what we're going to do is set up the brackets like this. So we're going to set up 2 brackets. Now I know there's going to be an x in both brackets because I need x times x to give me x squared. What I need to do is put in 2 numbers with the x. So I'm going to put a number here and a number here. So the 2 numbers that go in these boxes are 2 numbers that multiply to the constant term. They multiply to the term that has no x's, and they add to the coefficient of x. That's what I mean by times plus rule. So we need to find 2 numbers that multiply to 8 and add to 6. So if I didn't know them off the top of my head, I'd go through factors of 8. 8 and 1 doesn't work. 4 and 2, that does work. So the numbers that go here are 4 and 2 because 4 plus 2 is 6, 4 times 2 is 8. If I were to expand this using FOIL, I would get that. It, of course, wouldn't matter if I wrote x plus 2, x plus 4, if I switched the order of the brackets because they're being multiplied. So for something like x squared minus 10x plus 25, once again, 1, 2, 3 terms, it's a trinomial. So we get our 2 brackets. So I put an x in each bracket, and then I find 2 numbers that multiply to 25 and add to negative 10. So in this case, they're both minus 5. Negative 5 times negative 5 gives me 25. Minus 5 plus minus 5 gives negative 10. If I were to expand this, I would get that. And you might see the answer written like this. It's x minus 5 multiplied by itself. So these ones are a bit hard where the constant term is negative, but we're going to follow the same process. We're going to set up 2 brackets with an x in. Now I'm trying to find 2 numbers that multiply to negative 30 and add to negative 7. So I go through factors of 30, but because this is negative, 1 is going to be negative and 1 positive. So 30 and 1 doesn't work. 15 and 2 doesn't work. 10 and 3 does work. How would I make 10 and 3 a negative 7? Well, what I'd do is I'd make it a negative 10 and a positive 3. So that works because minus 10 times 3 is negative 30, minus 10 plus 3 is negative 7. So note, in all of these cases, there was no common factor. There was nothing that goes into all 3 terms. Up here, yeah, 2 goes into 6x and 8, but it doesn't go into the first one. That's why we needed a different method. Sometimes you will have a common factor if the number in front of x squared is not 1. So if I get a situation where there's something in front of the x squared term, we first take out that common factor. Unlike the previous 3 examples, this example, the 3 terms have a common factor of just 2. Not 2x, because the last term doesn't have an x. So if I divide everything by 2, 2x squared divided by 2, I say, what do I times by 2 to get negative 18x? Well, it's minus 9x. And then what do I times by 2 to get negative 20? Well, that's negative 10. So I've taken out the common factor. Now I can factorize this expression here using the methods I was just using. So I leave the 2 alone, 2 brackets with an x. I want to find 2 numbers that multiply to negative 10 and add to negative 9. So they would be negative 10 and positive 1. And then I'm done. I've fully factorized. All right, let's now look at algebraic fractions. So with algebraic fractions, you'll be given a couple of fractions. They'll be added, subtracted, multiplied, or divided, and you need to simplify it. So we'll start with multiplying and dividing, which is easier. So these are algebraic fractions because they're fractions both containing a pronumeral. When you're multiplying fractions, it's easy. You can just multiply the tops, 4 times y, multiply the 2 bottoms, 5 times x. So when you're dividing algebraic fractions, what you do is you keep the first fraction the same you flip the second fraction and make it a times. So I times 25z over 30xy squared. See, I flipped the second fraction. Now, whenever you have a multiplication like we did up here, you can cancel common factors. Anything on the top with anything on the bottom, and that will make it easier for us. So 5 and 25, for example, have a common factor of 5. So we do this. We go 5 goes into itself once. It goes into 25 5 times. Now, you can also cancel pronumerals or letters. So we can see that there's a z on the top and on the bottom. So I can just cross out that z. You can cancel anything on the top with anything on the bottom as long as it is a times. So we can do the same for other things here. So 12 and 30 share a common factor of 2. So 2 goes into 12 6 times, and it goes into 30 15 times. So then we have the x's and y's to cancel. So there is an x on the top and the bottom. So I can cross out this x. But on the top, there's actually two x's. X squared is x times x. So what I'm going to do is cross out the squared. So now there's only one x on top. And I do similarly for the y's. So there's a y on the top and the bottom. So I can cancel out a common factor of y. On the bottom, I need to cross out a y. So y squared means there are two y's. So what I do is I cross out the squared. So now there's only one y. So what I'm left with is this. I just go 6 times x times 5 gives me 30x. On the bottom, I've just got 1 times 15 times y, so that is 15y. That can be simplified further because 30 divided 15 is 2. So I'm left with 2x on top and a y on the bottom. So let's say I had to simplify a fraction like this. It looks very difficult. When you have expressions on the top or bottom and you're timesing or dividing, use the F word factorize. We're going to simplify this by factorizing. So we still do the same thing in that we keep the same fraction, first fraction the same. We flip the second fraction and make it a times. So what we don't want to do now, because these are complicated expressions, we don't want to times this by this and this by this. What we want to do is factorize everything on the top and the bottom and then cancel. So for the first fraction, x plus 3 can't be factorized. So let's look at the bottom. So this is a quadratic trinomial. I find two numbers that times to negative 15 add to positive 2. So they are 5 and minus 3. So then for the other ones, I can factorize this expression. It is a binomial, highest common factor x. And I factorize it like this, and the bottom is similar. It's x outside of x plus 3. So now what I can do is cancel anything on the top with anything on the bottom. So I can cross out the x plus 3's because they're being times. I can cross out the two x's. I can cross out the two x plus 5's. So what I'm actually left with is on the top, there's nothing there. So it's like a 1 there. So I can just write 1 if there's nothing left to multiply. And then on the bottom is x minus 3. That can't be simplified any further. All right, now let's look at adding and subtracting algebraic fractions. Now, adding or subtracting fractions is easy when they have the same denominator. So if you had something like 7 over k plus 2 over k, that's easy. You add or subtract the numerators, the top numbers, 7 plus 2 is 9, and you keep the same denominator. You never add or subtract the bottom numbers, the denominator. If I had 7 over k minus 2 over k, it's similar, except instead of doing 7 plus 2, I do 7 minus 2. Once again, keep the same denominator. So the tricky thing with adding or subtracting fractions is when they don't have the same denominator, you need to first make them have the same denominator. So let's say I wanted to add a over 2 and 2a over 3. So this is a bit tricky because their denominators are not the same. I can only add or subtract fractions when their denominators are the same. So don't try and add the tops and add the bottoms. That's completely wrong. I need to make them have the same denominator. Now, the lowest number divisible by 2 and also 3 is 6. What I'm going to do is times each of these denominators by something so that they become 6. 6 is the lowest common denominator, the lowest common multiple of 2 and 3. So if I times this bottom by 3, this denominator will become 6. If I times 3 by 2, this denominator will become 6. So both fractions will have the same denominator. Now, if I times the bottom by 3, I have to times the top by 3. If I times the bottom by 2, I have to times the top by 2. What you do to the bottom, you must do to the top. So what I'm going to do now is write a over 2 as 3a. A times 3 is 3a over 2 times 3. Now I'm going to do 2a times 2 gives me 4a. 3 times 2 is 6, and I'm adding them together. Now it's easy to add them together. I just do what I did in a previous example. So I just add the two tops together, 3a plus 4a, and I keep the same denominator. Then I'm done. All right, now we're going to look through linear equations. So on your screen are two linear equations, and what we want to do here is solve. So this is actually different. When we were using algebraic fractions, we wanted to simplify them. Previously, we wanted to expand or factorize an expression. Now we want to solve. What we want to do is find a value we can substitute for the pronumeral, the letter, in this case x, that will make this a true statement. So the way that you do linear equations, you undo everything that's been done to the pronumeral in the opposite order to BIDMAS. Now, I want to make this point. The order in which you do the operations here is vital. What we're saying is a lot of things have been done to x. We're going to undo them in the opposite order that they were undone. It's like dressing and undressing. You know, when you get dressed in the morning, you put on a shirt, then you put on a jumper. But if you wanted to get undressed, you need to take off the jumper first because that was the first thing that you put on. So when you get undressed, you're taking things off in the opposite order that you put them on. And that's the same as what we did here. So here, for x over 5 minus 3 equals 8, what we've done is we've taken some number, x, we don't know yet, divided by 5 and then subtracted 3. We divided 5, then subtracted 3 because of BIDMAS, order of operations. So when we're solving, because minusing 3 was the last thing we did, it's the first thing we undo. So we're going to undo subtracting 3 first. So the way I undo subtracting 3 is by adding 3. So I'm going to add 3 to the left-hand side. But if I add 3 to the left-hand side, I must do also to the right-hand side. Whatever you do to one side of the equation, you must do to the other. So if I subtract 3 from the left-hand side, minus 3 and plus 3 undo each other. That's why I added 3, to get rid of that. So what I'm left with on the left-hand side is x over 5, and on the right-hand side, 8 plus 3 is 11. Now I'm going to undo dividing 5 by timesing each side by 5. Times 5, divide 5, undo each other. So on the left-hand side, I'm left with x. On the right-hand side, 11 times 5 is 55. This is my solution. If I substitute x for 55 into this equation, I get a true statement. 55 divided by 5 minus 3 does give you 8. You can check it on your calculator. So let's look at this equation here. Now, you might be thinking, well, isn't this exactly the same? It's actually not. The only difference between these two equations is the order of operations, but it means they're going to have completely different solutions. So in this example, I've taken an unknown number, I've subtracted 3, then divided by 5. So when I'm solving, instead of adding 3 first, I need to first times each side by 5. I need to undo the division first because it was the last thing I did. I subtracted, then divided. So the first thing I undo is dividing by 5 by timesing by 5. So times 5 and divide 5 undo each other. On the left-hand side, I'm just left with x minus 3. On the right-hand side, I have 8 times 5 is equal to 40. So now I'm going to undo subtracting 3 by adding 3 to both sides. So if I add 3 to both sides, I now get x equals 43 plus 3 minus 3 undo each other. So x equals 43 is my final solution. If I substitute x for 43, I get a true statement. The solutions here were different because the order of operations was different. So if you do things in the wrong order, if you undo what's been done to x in the wrong order, you will get the wrong answer. So now let's look at an equation involving algebraic fractions. So this is a tough one. What we're going to do is we're going to combine this into a single fraction so it's easy to answer. So here we are subtracting an algebraic fraction from another. So remember they have to have the same denominator. So what I'm going to do is I'm going to times top and bottom here by 5, and I'm going to times top and bottom here by 3. So the first fraction, 2x times 5 becomes 10x, and 3 times 5 is 15. The next fraction, I times x plus 1 by 3 and 5 by 3. And that still equals 4. Now, I didn't do anything to this right-hand side. You're probably thinking, well, doesn't this go against what you just said? But the reason is I haven't actually started solving yet. I haven't undone anything that's been done to x. All I'm doing first is making this a lot easier to work with by combining it into one fraction. So what I have is, remember I just take the numerators and subtract them. So minus 3 times x, and then minus 3 times 1 over 15 is equal to 4. So I can simplify this fraction here even more. So what I get on top, 10x minus 3x is 7x. I've still got the minus 3 by itself. I didn't do anything to it. Over 15 equals 4. Now I'm going to start solving. I haven't actually undone what's been done to x yet. So I'm going to solve this by timesing each side by 15. That gets rid of the fraction here, times 15, and divide 15 undo each other. So I get 7x minus 3. 4 times 15 is 60. Now I'm going to undo subtracting 3 by adding 3 to both sides. And finally, I'm going to divide each side by 7, and I get 63 divided by 7 is 9. That's my final solution. So now let's quickly go through what we would do if the pronumerals on both sides of the equation. So let's look at this equation here, 6x equals 4x plus 48. The x, the pronumeral, is on both sides of the equal sign. When that happens, what you need to do is subtract the pronumeral with the lowest number in front of. I'm going to subtract 4x from both sides. 4x minus 4x, they cancel out. So on the left-hand side, 6x minus 4x is 2x. On the right-hand side, I'm just left with 48. Divide each side by 2, and I get x equals 24. How easy is that? So when you have x on both sides of the equation, subtract the one with the lowest coefficient. So let's do this equation here. So what I'm going to do first, before solving, is I'm going to expand the bracket. So go 5 times 3x, 5 times positive 4. Now, the x with the lowest number in front of is this one, which is a minus 2x. So what I'm going to do is subtract negative 2x from both sides. But subtracting negative 2 is the same as adding. What I'm doing is adding 2x to both sides to get rid of the x on this side. So 2x and minus 2x cancel each other out. So now I will have 3 equals 15x plus 2x is 17x. Like this. I only know how to solve equations when the x is in one spot. That's why I need to do this. I need to get x to one spot first before I can solve. So now this is really easy. I'm going to subtract 20 from both sides and divide each side by 17. So I get minus 1 is x, or x is minus 1. So now we're just going to do a couple of word problems involving linear equations. All right, we'll do these two worded questions here. Starting with this one, a cruise ship charges $220 booking fee plus $130 per night. How many nights could I book for $1,000? So whenever you're solving worded problems with equations, you always start by letting x, or whatever letter you want, be the thing you're trying to find. So we're going to let x equal the number of nights, because that's what I'm trying to find, how many nights I could book. So now I need to turn this worded information into an equation. So all I do is I say, so I'm paying $220 plus 130 per night, because x is the number of nights, is equal to 1,000. Once I've got the equation, I just solve it like normal. So I'm going to subtract 220 from both sides and divide each side by 130. I get x equals 6. So therefore, I could stay for 6 nights. I could book for 6 nights and pay $1,000. So this second question is a little bit more difficult because I'm finding two quantities. So Nick and Ryan have $400 between them. Nick has $150 more than Ryan. How much does each person have? I need to find how much Nick has and how much Ryan has. So when finding two quantities at once, the same thing, I need to let x equal one of the things I'm trying to find. So it's usually easiest if you let it be the smaller quantity. So I'm going to let x equal the amount of money Ryan has, or Ryan's number of dollars. So I don't want to use another pronumeral for Nick. I only know how to solve equations when there's one pronumeral. So instead of letting y be the amount that Nick has, because he has 150 more than Ryan, Nick has Ryan's plus 150. So Nick has x plus 150. So now I can easily turn this into an equation. Ryan's money plus Nick's money is equal to 400. So x plus x is 2x. Now I solve this like normal. I subtract 150 from both sides, divide each side by 2. X is 125. So I found that Ryan's amount is 125 because his was x. So that means Ryan has 125 and Nick has 150 more than that, which is 275. So make sure you have a sentence here that answers the question, because it told us how much does each person have. It didn't tell us just to find x or just to find the amount Ryan has. We need a sentence to say how much Ryan has, how much Nick has. All right, that's all for algebra. Let's move on to percentages. So to find a percent of a quantity is easy. You've been doing it for a long time. Percentages are just fractions or decimals. So 30% means the same as 30 over 100. So if I want to find 30% of 60, I can just times 30 over 100 by 60. But you can also do this another way. You can also change 30% to a decimal. To do that, just go 30 divided by 100 on your calculator. 30% as a decimal is 0.3. 30 over 100 and 0.3 are the same. Once again, of means times. So to find a percent of a quantity, you just change the percent to fraction or decimal and then times by the quantity. So in each case, if you put it on your calculator, you should get $18. How easy is that? It turns out when we're increasing or decreasing by a percent, we're just finding a percent of a quantity. So let's say I wanted to increase 240 by 2.5%. So if you're increasing by 2.5%, that's the same as finding 102.5% of 240. You're taking 240, which is 100% of 240, and adding another 2.5%. 100% plus 2.5%. So the quick way to do it is this. I can just take my 240 and times by 1, which is 100% plus 2.5%. I can just put that on my calculator and get $246. Now let's say I wanted to decrease 1800 by 92%. So we've got a whole 100% and I want to take away 92% of that. So there will be 8% left. Decreasing by 92% is the same as finding 8% of the quantity. So to do this the quick way, I could just take 1800 times by a whole minus 92% of it. And so putting that on your calculator, you get $144. It's just the same as finding a percent of a quantity. So here are the formula you need to know. To increase by R% times by 1 plus R over 100. To decrease by R% times by 1 minus R over 100. That's the only difference between these two formulae. Plus when you're increasing, minus when you're decreasing. And that's what I used here. When increasing by 2.5%, I times by 1 plus R over 100. When decreasing, it was 1 minus R over 100. So make sure you know these formula. We're going to use them in exponential growth and decay. Just before that, we're going to look at finding the original amount. So please make sure you understand this rule because everyone always forgets it. So in the previous slide, when we were looking at increasing by a percent or finding a percent of a quantity, we multiplied. We multiplied the percent by the quantity. Whenever you're trying to find the original amount, you don't multiply, you divide. So let's look at this question here. 22% of a number is 55. What is the number? It isn't asking us what is 22% of 55. It's saying we took a number, then we took 22% of it, and we ended up with 55. We're asked for the original amount. What number did we have originally so that when we took 22% of it, we got 55? So what we're going to do to find what's in the box is sort of like solving an equation. So 22% is 0.22 of means times. So 0.22 times what's in the box is 55. So to find what's in the box, we can undo timesing by 0.22 by dividing by 0.22. We just go 55 divided by 0.22, and the answer you get there is 250. That's the answer because if you take 22% of 250, you get 55. So it's okay if you skip these first steps and you can go straight to this one. So we divided quantity by percent this time. Previous slide, we times together, but because we're finding the original amount, we divided. So the price of a car discounted by 28%, it now costs $12,960. We want to know what the price was before we applied the discount. So here, once again, we are finding the original amount. We're finding what price was it, what number do I discount by 20% in order to get $12,960. So here we are finding the original amount we're going to divide. So I want to make sure you understand. What we're not asking is take this number and discount by 28%. We're saying what did we start with to discount by 28% and get this. Another thing you need to know about this question is if we've discount something by 28%, we can't just increase the new price by 28% to get back where you started. So you can't just take this number and increase by 28%. That won't give you the right answer. Instead, whenever you're finding the original amount, you divide instead of multiplying. So if we were decreasing or discounting something by 28%, what we normally do is we times by 1 minus 28 over 100. Because this is finding the original amount, we divide. All we do is go 12,960 divided by 1 minus 28 over 100, and we get our original price of 18,000. That's the answer, because when you discount this by 28%, you get this. Okay, that's our final answer, and we'll now move on to exponential growth and decay. So we'll now look at exponential growth and decay. For our purposes, this is when you have a quantity that either increases by the same percent each time or decreases by the same percent each time. So this question gives you an example of that. So population of a town, 42,000, decreasing by 2.1% each year. We're going to find the population in 10 years' time. So what's happening with the population of this town? It would decrease by 2.1% of 42,000. It would decrease by 882 people in the first year, decreases by about 863 in the second year, then maybe around 846 in the third year. It's decreasing at a decreasing rate. The number of people leaving the town is decreasing each year. but the percentage is the same. So we can just use this formula up here. So it's A, the amount you have, equals P, the initial amount, times 1 plus or minus r over 100 to the power of n. So r is the rate of increase or decrease, n is the number of increases or decreases. So this formula, you use a plus if it's exponential growth, if it's increasing each time, and you use a minus if it's decay, if it's decreasing each time. So in this case, it's decreasing each time, so we are going to use the formula with a minus. So what we have is A, the amount, the number of people that will be in the town, is equal to P, the initial amount, times 1 minus, because it's decay, the rate over 100, and the power is the number of increases or decreases. So here, it's each year for 10 years. We can just put this straight on our calculator and it will give us the answer. So if we put this on our calculator, we get 33,968. That is to the nearest whole number. So that will be the population in 10 years' time. So now we're going to use trial and error to calculate how long before the population is below 30,000. So the population after n years is 42,000 times 1 minus 2.1 over 100 to the power of n. N here is the number of years. We need to find what value of n we can put here so that the amount will be below 30,000. So we know after 10 years, the population's about 33,968. So n will have to be a bit more than 10 in order for the population to go below 3,000. So unfortunately, we just need to use trial and error. So if we were to try, say, n equals 15, we get this. So putting this on our calculator when n equals 15, the answer we get is that the population is about 30,548. So it's just over 30,000. So now let's substitute n equals 16 into our formula. So putting this into our calculator, we get about 29,907. So you can see the population's above 30,000, just above 30,000 after 15 years, and just below after 16 years. So that means it will take 16 years. After 16 years, the population will be below 30,000. All right, let's finally look at compound interest. So compound interest is a type of exponential growth. So interest is what you earn when you invest money. The bank pays you to keep the money with them. So the amount of money you have increases by a certain percentage each year. So let's look at this question. I invest $6,000, 3% per annum. How much would I have after 5 years? So firstly, if interest is compounded annually, we're just using this formula because compound interest is exponential growth, and that's the formula for exponential growth. The amount you have would be the initial amount times 1 plus rate over 100 to the power of n. So if it's compounded annually, compounded means when you recalculate the interest. If it's compounded annually for 5 years, you compound it 5 times, so 5 goes in the power. So putting this on our calculator, we get the answer 6,956. That's to the nearest dollar. So that's the amount that I have. So the amount I've earned in interest is just this minus this. I've earned $956 in interest. So I've got $956 extra from leaving the money in the account. Now, if it was compounded monthly rather than annually, it's the same formula, and P, the initial amount, is still the same, but we have to change R and N to be in the same unit. So compounded monthly, R was 3% per annum, which means 3% per year. So if it's compounded monthly, I need to change the interest rate to per month. So I'm going to divide by 12. So 3 divided by 12 is 0.25. So R is 0.5% per month. I also need to change N. So if I compound monthly for 5 years, I will end up compounding 12 times a year for 5 years. I will compound 60 times. That means I will increase or recalculate the interest 60 times. So the formula will be A equals P times 1 plus r is now 0.25 over 100 to the power of n, which in this case is 60. And so putting this on my calculator, I get about $6,970. So that's the amount I have, and that means I will have earned in interest $970. So you can see I earned slightly more in interest when it was compounded monthly than annually. The more frequent you compound, the more money you have. So let's just look at one final example with compound interest, and this time we'll be finding the initial amount. So let's do this question here. How much money would I need to invest at 4% per annum interest compounded annually if I want my investment to be worth $10,000 in 3 years' time? So this is asking us for the initial amount. It's saying, I know what A is. I want A to be $10,000. What is P? What is the amount I need to initially invest in order to get A to $10,000? So whenever you're finding the initial amount, you divide. So what we have is A equals P, which is what I'm trying to find, times 1 plus rate over 100 to the power of 3. So this time it's compounded annually for 3 years, so it's compounded 3 times. I didn't have to change R or N this time because it's compounded annually and we have years and per year. So this is the formula. So if I want to find what P is, I just divide. Instead of timesing 10,000 by this, all I need to do is take 10,000 and divide by 1 plus 4 over 100 to the power of 3. So you can put that straight in your calculator using the fraction button. And so putting that in calculated to the nearest dollar, we get 8,890. So that means if I invest this much at 4% per annum compounded annually for 3 years, I'll end up with $10,000. But once again, I divided amount by percentage because I'm finding the initial amount. All right, sorry for the long video. Thank you so much for tuning in. Best of luck in the test, but you'll ace it. You're a superstar. This has been the luckiest maths teacher in the world. Have a great day.